tools, we can now create our model. Okay. Now, if you're going to look at this, you will notice that this is a different subsystem, and this is also a different subsystem. Okay, so basically there are two subsystems here. So the first one is, this is the release of loan. So there are three, and this one here is the loan payment. So there are two subsystems here. So since there are two subsystems, basically there are two sets of people who will be using here. So the first will be those in charge of approving and releasing the loan, and the other group are those people who will receive payment. So more or less, the users on this subsystem are the cashiers. Okay, so we will now create an external model for this. So the external model here is a very simple model. Okay, so okay, mabasa ra ninyo ni kaning Word file.
Mabasa na, sir.
Okay, sige. Okay, so let's start with this. So we'll have this entity. So you'll put that here. So the name of that entity is, okay. Then the attributes are, okay, we'll just call it we'll just call it bin ID, and that's the primary key. Then we have name. Okay, it's a composite. So we'll discuss later how you're going to show a composite attribute. Then we have address. Okay, we'll just use an abbreviation. Then we have occupation. And then we have marital status, or that is civil status. There. And then number of children, and lastly we have the balance, or just call it loan balance. Okay, so that's the first entity. The second entity is the entity loan. So we will put it here. That's loan. And then the attributes are a loan ID. And it's a primary key. Then we have loan name. And lastly, we have okay. Then the association is okay, avail. Oops. Okay, by the way, before we proceed, if you look at the narrative, it says here that the organization will keep track of this data here. So basically, it's not an ordinary relationship. It is actually an associative entity. So instead of this diamond, we will use this. Okay, we'll put it here, and then we will give it a name. We'll just call it beneficiary loan, or we'll just call it pen loan, and it is an associative entity. It becomes like that. Okay, so we'll now connect the two. Then we have the cardinality. Now, originally, the cardinality here is 1 on this side, okay, that's the original. And then here, it is, oh, sorry. Okay, so this is the original cardinality. So a beneficiary can have one loan only at a time, and one loan can be availed of by more than one beneficiary. But since we have converted our relationship into an associative entity, so we have to put cardinalities here on this side. Okay, so this is what will happen. Now, since there are many beneficiaries who can make a particular loan, then one loan or one instance of a loan can be here more than once. So this becomes like this. Okay, and then here we will reverse this. So one instance of a beneficiary can have several loans later on. Okay, so this becomes the cardinality of the external model. Okay, so this is the external model. Okay, question on this? Okay, so this is the external model for release of loan, and then the next one is payment. By the way, yun na. Okay, so payment. Now, payment involves beneficiary and loan. So the same call this the same entities. Okay, okay. Next we will copy this, put it here. So this is the beneficiary, so the same entity, and then we'll also copy this. And then what will be the association? So the association here is the verb pay. But then again, if you look at the narrative here, it tells us that the payment has attributes. So again, it's not just an ordinary relation. It will be considered as an associative entity. So instead, Okay, so just copy it here. But of course, it will have a different name. So normally, this will be named as payment. Okay. And then there. So what's the cardinality? So more or less, you will have one and many. And then here, okay. So those are the two different external model. Okay, so how do you make one model for that? Okay, so let's start with. By the way, any questions?
Sir, ang payment, sir, dili na siya associative.
Ay, sorry, associative. I forgot. Yeah, it's associative. Thank you. There. By the way, the loan will have this attribute. So you have to have an attribute here. Okay, the name here is voucher number. And it's the identifier. So this is a primary key. There, and then what else? Date. And then amount. Okay, so that's these are the attributes of this associative entity. And for this, you have official receipt. And it's a primary key. And then we have date of payment. And then amount. Okay, so that completes the two external models. So in actual practice, you have to create these diagrams on separate files because you'll be presenting this to different clients. But since we are here just to have an example, so just draw it in one file. Okay? Other clarifications?
Wala ra, sir.
How about the others? Okay na?
None, sir.
None, sir.
Okay ra, sir.
Okay ra, sir.
Sige. Okay, so we will now create the conceptual model for this. So we will make this two separate diagrams into one. Okay, so let's start with payment. And just copy this. Okay. Okay, so this is the loan, and then we will now, okay, this is the loan side, okay, this part, and then to merge the two, so we have to include this also. But if we look at these two are the same. So rather than creating another entity named beneficiary, so we'll just use this. Okay. So we will put here the entity payment. Okay, so who is going to make a payment? So it is the beneficiary. Okay, so we will use this. Okay, then since this is also loan, then we'll connect it here. Okay, so this will be okay. This is now our conceptual model. Ah, sorry, it still lacks this. Okay, this now completes our conceptual model. Okay, so that's how you connect or merge two or more external models into one. Okay, questions? Okay, okay. So we'll go to our next topic. Okay. Okay, so this is another model. So this is called the entity relationship modeling or AR modeling. Okay, so the entity relationship model will be the basis of our entity relationship diagram, or basically you can just interchange these two terms. Okay, so it normally shows us the main components of the model: entities, attributes, and relationships. Okay, the first concept in ERM is the classification of a required attribute and an optional attribute. Okay, so there might be many attributes for any given entity, and some of those entities or most of those entities are normally required, but there are some which can be optional. So normally attributes were in at some point a particular instance of the entity cannot have that particular value, and sometimes an instance of an entity can have that value, then that's where we consider that attribute to be optional. But when the attribute is really important, then we normally consider it as required. Okay. Before we will differentiate the two, let's discuss this first. Okay, so you have this value null. Now, in databases, null is equivalent to simply nothing, but null is not the same as empty. Okay, for example, you have an attribute, say you have this attribute address, and then the value of this attribute is, let us say, Dumaguete City. Okay, that's the initial value of this attribute address. Now, what would be the value of the attribute address if we are going to delete this? Okay, probably you might say the value is null. Okay. Now, actually, the value of address right now, since we have deleted it, is actually an empty string. So actually, there's no value anymore because we have deleted it. But in databases, when there was an initial value, especially for strings, and if you're going to delete that, then it's not equal to null, but rather it's equal to an empty string. Or if you have a numeric value, say the value is 5, and then you delete 5, then the value of that numeric attribute is not null. Okay, because there was a value already and then you remove it. So when can an attribute have this value? Okay, an attribute will have a value null if when you added a record, you left that attribute blank, which means you did not put any value, or you did not input any value for that particular attribute. So if you did not put any value at all, then the value is null. Okay? Again, if there was a value, you delete it, it's not null. It's simply empty. Okay? So let's go back to the difference between required and optional. So an optional attribute is normally an attribute wherein we allow that attribute to be left empty at the time the instance is added. So when you add a record, and then if it is allowed that that particular attribute can be empty, then that attribute is termed optional. Because if it's not optional and then you don't put any value, normally the DBMS will trigger or will throw an exception. So it will tell you that data is lacking. Okay? So again, if it is allowed that when a record is added, a particular attribute or probably a set of attributes can be left empty, then we call that attribute optional. So who will identify or who will set whether that attribute is optional or not? Of course, the one creating the table. So you will set there, if you are the one making the table, so you will set that if this attribute is allowed to be empty, then you set it as optional. Otherwise, you set it as required. So, how do we know that we will have this attribute required or we will have this attribute optional? Okay. One example is, what if you have this attribute? You have an employee table. One of the attribute is named, spouse. How do you consider that attribute? Would it be required or would it be optional?
Optional,
Anyone?
sir.
Why?
Because like dili siya relevant kayo.
Dili kayo relevant. Any other?
Depende, sir, if
Come again?
for example, sir, like may ubang mga, like for example, mga hotel na nag-require sila na mo input kung kuan inani na data, napayo pa na dili. So, I don't know.
Okay. Let's just make. Okay. Let us say you have this table. Okay, the table is named employee. So the company normally keeps track of the personal details of their personnel. And one of the possible attribute that will be there is this attribute, spouse. Okay? So would you make this required or would you make this required? Okay, so to answer that, whether this will be required or optional, is to ask this question. Is a person always married at all times?
No.
Not so.
No, sir.
Okay, so not all employees are married. And you cannot force a person just to have a data for this to get married. So there are employees who are single at the time they join the company, but there are some who are already married when they join the company. So for this particular attribute, so if the employee is single, then that employee has no spouse. But if that employee is married, then obviously there is one. So, which means that this particular attribute is not always filled up. So when the employee is single, then this is empty. So this is allowed to be empty. But when the employee is married, then you fill this up. So in this case, this particular field should be optional. Meaning, actually, it says here, allowed to be left empty, but it doesn't mean it's always empty. So probably, for an employee who joined the company as single, so at the time that the record is added, then this is empty, and eventually that employee will get married. unless you're a priest. Okay? So this is an example of an attribute that is considered optional. Okay? What else? Another example wherein we consider a particular attribute as optional is, I think I have mentioned this already. Middle name. This has to be optional also. Okay, why optional? Because there are some culture wherein they don't have any middle name. So if that particular person will join the company as one of the employee, then you cannot force that person to have a middle name, or you cannot just simply input something so that this particular attribute will have a value. So if that person has no middle name, then it should be blank. Because if you add something else, then that's not the name of that person anymore. Okay? So that's why it's not always that a person has a middle name. So that's why it's an example of optional. Okay? Another example of optional is phone number. Okay? So, not all people has a phone, either a mobile or landline. So, it's not a good idea to have that attribute phone number to be required. It should be optional. Unless that the company will require all applicants to have a phone. Well, if that's the case, then it's another story. But without that policy, then that should be optional. Okay? So, again, how do you distinguish required from optional is you ask the question, is this attribute will always have a value? So again, if we go back to our example, like spouse, can that have always a value? Well, it depends. So if the answer is like that, it depends, then it should be optional. Okay? So the opposite is required. So it is an attribute that must have a value at the time the instance is added. So when you add the record, then that particular attribute should have a value other than a null. Okay, null is also a value, but this is not allowed. Okay? So, an example of a required attribute are primary keys. Now, primary keys are those that will differentiate one record from the other. And because of that, there should always be a value for that particular attribute. So a primary key is an attribute that is required. Okay, another is last name and first name. So all of us have last name and all of us have first name. So that's required. Gender, that's also required because all of us have gender. And it is important that's important for the company because there are benefits that are for this particular gender only that the other gender cannot claim. Okay, one example is maternity leave. So male employees cannot enjoy maternity leave. Only female. So that's why it's required. Okay, so I think the difference between required and optional is now quite clear. Okay, the next concept about entity relationship modeling is this concept on domains. Now, a domain is a set of possible values that a particular attribute can contain. And normally, it will be written something like this. It will be enclosed in parentheses, wherein there are only two values inside the parentheses. The left side is the minimum, the right side is maximum. And of course, when you have minimum and maximum, that's only applicable to numeric values. So for text values, there is the minimum maximum. Okay, so examples of domain, you have here gender. So you have M and F. So actually, in this case, there is no minimum maximum. So actually, it's exactly valid if you have F and M on the right side. Basically, what does this mean is that the possible value of this attribute are limited to this range. And since this is a text, then there are only two here. Okay, another example is QPA. So the domain for a QPA is from 0 to 4. Now, since these are numeric value, then 0 is obviously the minimum and 4 is the maximum. And then values will be either between 0 and 4. What does this mean is that there's no QPA that is less than 0, and there is no QPA that is greater than 4. And then another example is years of service. So you have here 0 and 30. So the minimum is 0, the maximum is 30. So that means, of course, no years of service will be less than 0, and there will be no year of service greater than 30. So what does this imply? So that means if you are already serving the company or any institution for 30 years, in this case, you are bound to retire. Okay? So these are examples of domain. So basically, we set limits of possible values. Now, there are cases wherein we don't explicitly put the domain. So one example of that is name. It's really quite difficult to specify what names are allowed. That's because there are many names, and there are names that are outside the common. Sometimes there are names that are all consonant, which is very weird, but there's nothing you can do about that. That's the given name. So that's why in many cases you don't put the domain for names. So the only domain for names are all the texts that are allowed. Okay. Another thing about domains is that attributes may share domain. So there might be different attributes that may have common domains. Okay, an example of that is like you have a so you might have an entity, you call it customer, and then you might have another entity which you call employee. So for the entity customer, you might have this attribute. And then for employee, you might have this attribute also. So basically, these are two different attributes. You have cost ADDR and imp ADDR. So they are different attributes. But these two will share common domain. And that domain is the set of addresses. Okay, so it's possible. Okay, next to domain, we have the term identifier. And actually, an identifier is synonymous to primary key. So in the ERD, we normally call it an identifier, which basically a primary key. So that means the definition of an identifier is the same as the definition of a primary key. So it is a set composed of one or more attributes that we normally use to differentiate one instance to another. And these identifiers are mapped to primary keys in the table, and in our model we normally underline. So we have been doing this already. Another term is composite identifiers. That's referring to this. So it's simply a primary key that is composed of more than one. Okay. Now, next term is we have this composite and we have simple. Now, do not be confused between composite identifier and composite attribute. Okay, so they're not the same. Because what do we mean by attribute is it could be any. Not necessarily it will differ one record from the other. Okay, so what's the difference between a composite and simple attribute? So a composite attribute is an attribute that can be subdivided such that the result will be several attributes. Okay? Now, a good example of a composite attribute is address. Okay? This is an example of a composite attribute. So, like, you might have this address, like 5 or number 5 ABC Street, okay, so this is an address, and this is an example of a composite attribute. Why is this considered a composite attribute? Because we can subdivide this data, and the result of subdividing this data will result to new several attributes. So if you're going to subdivide this, then this single attribute named address can become 3 attributes. So one attribute will be the street, the other attribute will be city or municipality, and the other attribute is province. So the one attribute named address is now subdivided into 3 attributes. You have the street, city or municipality, and the province. Okay, so that's what we call a composite attribute. Okay, that can be divided. Is it really necessary to subdivide? Well, that would now depend on your client. So if your client doesn't care about in what street, in what city, or in what province, what is important is they have an address, then there is no need to subdivide. That composite address is sufficient already. But there are companies that really needs this to be subdivided, especially the marketing department of any organization, because they might need a specific data from a specific city, or probably they might need specific data based on what province. So if that is their need, then obviously they require that the address will be subdivided into these things here: street, municipality or city, and province. In that case, you have to subdivide your composite. attribute. Okay, the next is a simple attribute. So a simple attribute is an attribute that cannot be subdivided into several attributes. Okay, one example of a simple attribute is your first name. Probably your first name will be composed of 3 names, but there is no way for that to be subdivided. Okay, most of you have 2 names, diba? Or most of you have 2 first names. But of course, there is no way, or there is no relevance of subdividing your first name, because it won't matter if you're going to subdivide it. And in fact, if you're going to subdivide your first name, then that's a different person already. Okay, so you cannot really subdivide your first name. But name, this only is a composite. So name is a composite, because you can subdivide name as first name, middle, and last name. But first name, you cannot subdivide it. Okay? So that's the difference between composite and simple. And then next, it's still about an attribute. We have a single valued attribute, and the other one is a multi-valued attribute. So what is the difference? The difference is a single valued attribute is an attribute that can have only a single value. So saragyod ang iyahang value. So it will never happen that it will have multiple values. So examples here are, okay, social security number. You have student ID number. Okay, so these are examples of single valued. Why this is called or classified as single valued number or attribute? That's because for every person in this planet, that person has only one social security number. Okay, this is a government given number. So the government will only give one value to each individual. This is also a single valued attribute because for each student in a particular school, that student will only have one ID. So even if if you had graduated already, and then you're going to came back to study, probably graduate studies or probably take another degree, the school will still use the same ID, or you will still be using the same ID as what you had before. Okay, so that's why this is a single valued number. But a single valued attribute is not necessarily a simple attribute. Okay? So there can be a single valued attribute that is composite. Okay, for example, SUID. I think the SUID is 2-digit, and then dash 2-digit, and then how many here? 5. Is this correct? Is this
One
the
digit sa middle, sir.
Ha? Pila ning middle?
One.
Only one. Only one. Okay. How about the last? How about this? Is this correct? 5.
Sakto na, sir.
Sakto sir.
Okay. So basically, this is the format of your ID. So probably you might have something like 18-1-00100. Okay. So this is an ID. This is a student ID. So since this is a student ID, then this is a single valued attribute. So one student will only have one value. But this is a composite. Okay, this is a composite attribute. Why is this composite? Because we can subdivide this into 3. This can be subdivided into year. The other is the semester. And the last is the ordinal value. What is your order when you came in? So in this example, this particular student came in the year 2018 on the first semester, and this student is the 100th student who came in. So in that case, you can divide it into 3 separate attributes. So this is, or an ID is an example of a single valued attribute and at the same time composite. Okay. Now the opposite of single valued attribute is multi-valued attribute. So it is an attribute that can have many values. So one example of a multi-valued attribute is degree. Okay. So a company, when they hire someone, they record normally the degree. So degree can be more than one, depending on the person. So some will have only one, some will have many. Okay, another example is dependent. Dependent is a multi-valued attribute. So an employee might not have any dependent, or the employee can have 1, or can have 2, can have 3, and probably can have 15. So it depends. Okay, so this is an example of a multi-valued attribute. So if there is, or if you think that an attribute can be classified as a multi-valued attribute, then this is how you are going to show it on the diagram. You're going to connect that attribute to the entity using a double line. So for example, you have this entity. Okay, so you have employee. Then you have the attribute degree. Now degree can be multi-valued. So to show that this is a multi-valued attribute, then we will connect this something like this. Okay? So for example, you have here imp ID. Now imp ID is not a multi-valued attribute, so we normally connect this with only one line. Okay, so that's how to differentiate a multi-valued attribute from a single valued attribute. Okay, so you have this two lines or a double line connecting the attribute to the entity. Okay, so this is allowed. It is supported, but there is a but there. If you think that it's or that particular attribute is a multi-valued, then you have to break it before you put it in your diagram. It's a good design practice to always subdivide or break the multi-valued into several attributes already, rather than waiting it to be implemented. Okay. Next is, okay, so how do we implement? So as what I have mentioned, it is allowed, but it's not a good design practice to have an attribute that is multi-valued in the diagram. Okay, so how do we resolve? So basically there are two ways here, but in my case I would prefer the second one. Okay, so let's look at the first one. Okay, the first one is, so within the original entity, you create several attributes for that multi-valued. So for example, let's go back to that example we have. So we have the entity employee. So we have here the attribute degree. So it's connected like that. Okay, so rather than showing it or presenting it as a multi-valued attribute. So it would be better to resolve it at an early time. So you resolve it while you're still on your ERD. So to resolve the problem using option letter A, then this will become like this. So you break down the multi-valued attribute degree to several new attributes. So probably we will have here degree 1, and you will put here degree 2, and then you will put here degree 3, and probably you will put here degree 4, and probably you will put here degree 5. Okay, so let's just stop up to 5. So that's what will happen to your employee entity. So instead of one attribute degree, which is multi-valued, it will become 5. So degree 1, degree 2, degree 3, degree 4, degree 5. So it's not multi-valued anymore. So if the employee has 1 degree only, then fill up degree 1. If the employee has 2 degrees, then fill up degree 1 and degree 2. If 3, then fill up degree 1, 2, and 3. If 4, then fill up degree 1, 2, 3, and 4. And then if 5, fill up degree 1, 2, 3, 4, and 5. Okay? So that's what will happen. The problem with letter A or option A is, what if you have 1,000 employees and out of the 1,000 you only have 10 employees who have 5 degrees. All the rest have only 1. So that would mean for the 995 employees, attributes degree 2, 3, 4, and 5 are empty. And that is a waste of memory. Okay? So that's one problem. The second possible problem with option A is, okay, right now there are 5. What if there is a new employee or newly hired employee who has, shall we say, 6 degrees? So where will you place the 6th? Well, the obvious answer here is you add 1, or you add another attribute. So you have to modify the table, and you have to also make some modifications to your program, because your program is limited up to 5 degrees only. There are now 6. So technically the 6th is not yet recognized by your program. So for that attribute to be recognized in your program, or so that the user can add or insert the sixth, you have to modify the program. So there's a lot of issues if you're going to choose option A. So option A will defeat the purpose of database management systems. It will now look like you are using a file system. Okay? So the most or the appropriate way of resolving a multi-valued attribute without having to modify your table and without having to modify your program is option B. So what you're going to do here is you're going to create a new entity out of that original multi-valued attribute. Okay? So how do we convert this multi-valued attribute degree? Then it will become like this. So you have the original entity, you have employee, so one of the attributes here, you have imp ID. Okay, so instead of creating 5 like this or 6 like that or 10 like that, we will make this attribute into an entity. So we will create here an entity. We will now call it degree. So this is now an entity. So probably you will put here degree number, which is your primary key, and then probably so that you can have the data BS IT, BS ComSci, BS IS, or BS Mechanical Engineering, and so on. You may put here, you create another attribute, and probably you will call it degree name, and then connect that there, and then you put the relationship has there. So one employee can have one or more degrees. So this attribute becomes this. So regardless of your employee will only have 1 or may have 50, there's no need to modify the table. And of course, you don't have to modify your program. You only need to relate which employee will have which particular degree. Okay? So that's how you resolve multi-valued attributes. So when you create your entity relationship diagram, try to evaluate each attribute and try to think if it's possible that the attribute will be multi-valued Okay? And if you think that the attribute can become a multi-valued, then don't waste your time showing that attribute like this, okay? So don't anymore show in your diagram that this particular attribute is a multi-valued attribute. Convert or resolve it right away. So if you are creating a program for human resource, so normally you're going to encounter something like this. So when you come across with this particular attribute, then do not put that attribute here anymore, because you know that it's multi-valued. You right away convert this attribute into an entity. And to relate this attribute converted to an entity to the original entity is use this verb. Okay? Employee has degree. Question on this? Questions?
Wala.
Okay. Wala ra. Sige. Okay, we have discussed this already, so let's just skip this. By the way, derived attributes need not be stored. Meaning, you may opt to store it, or you may opt not to store it. So here are the advantages and disadvantages of storing and not storing a derived or calculated attribute. So for storing a derived attribute, these are the advantages. It will save CPU processing cycle. It will save data access time. Data is readily available. Can be used to keep track of historical data. Okay? So, why does it save CPU's processing cycle? Well, the obvious reason here is if it is stored, then the value is there already. So if you need the value, then all what your program does is access it. So the only CPU time needed is to access the data. Okay, so that's why it will save. Because if you did not store it, then before you can have the data, then you have to calculate it. And of course, when something is calculated, that requires CPU time. And calculation is or requires more processing cycle than just simply accessing it. So in a way, it will save CPU processing time. Saves data access time. Well, the data is there already, so all you need to do is access it. Okay, so for example, this attribute, age is a derived attribute. So why will it save access time if it's stored? Well, okay, if it's stored, then the access is direct. You directly extract the data. So that's the only time spent to get the data. But if you are going to calculate it first, then you have to, aside from this field, you have to access the date of birthday. So you have to access that, get that data, and then use that data to calculate the grade, to calculate the age. So it takes time. It accesses a data which is not the one that you need, but you don't have a choice because that's the only way that you can get the age. So you have to access the date of birth, and from that data you have to do some calculations. It will require time to calculate before you have the value. So if it is not stored, it requires more time than if it's there already. Okay, so that's the advantage. So what is the disadvantage, or what are the disadvantages if the data are stored? Okay, it requires constant maintenance to ensure the derived value is current, especially if any values used in the calculation will change. So, again, a good example of that is age. Okay, so for example, if the date of birth, let's just use the year. Okay, supposing the person was born in 1980. So, what's the age of this person in year 2001? So obviously that's 2001 minus 1980. So the person is 21 years old. Okay, so you store this. So it's there in your database. So year 2005, you access the age of that person. So what will you get is the value 21. So the big question is that the accurate age of that person? Well, the answer is obviously no, because that's the age of that person way back in 2001. So if you really want that the age is always current or is always accurate regardless of what year, then you have to always recalculate. So in 2005, you have to recalculate so that it will become 25. And then in 2006, you have to recalculate so that it will reflect 26. And then 2007, you have to recalculate to reflect 27. So you really have to do this every year. So that's what we mean by it will require constant maintenance to ensure that the value is current. That's a disadvantage if you store the age. So if you are not storing it, and there's no need to constantly recalculate. You only calculate if it's needed. Okay? So that's the advantages and disadvantages of storing it. And then not storing. What are the advantages? It saves storage space. Because you are not storing it, then obviously it won't require any space. anyway, the saving, or it could be justified because you can recalculate that. Another advantage is it will always yield a current value. So if you're going to calculate that value now, then that value is current. So if we go back to our example, if that person was born on this year, and then we're going to calculate the age of this person, then the result is current. That's the age of that person right now. Okay? So there are only two advantages of not storing it. What are the disadvantages if you are not storing it? Well, it will use CPU cycle time. Okay, it will increase data access time, adds coding complexity to queries. Okay, so basically, if you're going to look at this disadvantage of not storing becomes the advantage if you are storing it. So that's the equivalent, and then this will correspond to that. Okay, so are you to store a derived attribute, or are you not going to store it? Well, it depends on the need. So just weigh in between these two advantages and disadvantages. So probably if seldom you need that data, then probably don't store it. But if you constantly are using it, then probably store it. Okay? So there is no exact rule on whether you're going to store a derived attribute or not. That depends on the need. So you have to consult that with your client. How often they need it, or how seldom they need it. Okay? So that's about derived attributes. Okay, we have discussed this already. So for relationships, we normally use verb, and it could be active or it could be passive. And then cardinality, we have discussed this already, so I'll just skip this. Okay, there is what we call a weak relationship. Okay, remember, you have entity 1, and then you have this relationship. So entity 1 is related to entity 2 based on this. So there are two types of relationships. We have the one here, which is weak, and the other one is strong. So let's look at what's the difference. Now, a weak relationship exists. So meaning we can say that this particular relationship is weak if the primary key of the related entity. So remember, this entity has a primary key, so let's call it P1, and then this entity has its own primary key, we'll just call it P2. So the primary keys of the related entity, this phrase is referring to these two here. So these are the related entities. These are their corresponding primary keys, and that's what is referred to by this. So if these two does not contain, or if this relationship does not contain the primary key component of the parent, then we call it a weak relationship. Okay, we have here an example. Okay, we have this entity called course. So this can be drawn like this. So the primary of course is CRS code. And then we have an entity here, class, and the primary key of this entity is class code. There. So obviously the relationship here is has. So one course can have one or more classes or one or more sections. So you will notice that this entity, when it is converted into a relation, you will notice that there is a specific primary key other than the primary key of the parent entity, which is course. So you will notice here that this is the primary key of the parent entity course code. And you will notice also that there is no underline, for this attribute is not underlined. Now, since course code is not underlined, then that means course code is not part of the primary key of this relation class. Now, since this is the primary key of the parent and it's not part, or it is not included in the primary key here, then we call this relationship weak. Okay? So how about for a strong entity? You will notice the same example, the same parent entity, the same child entity, course and class. And you will notice course code is the primary key of the parent. And you will notice now that the primary key of the relation class consists of class code and class section. So what happens here is that the primary key of the parent entity is included here, or it becomes part of the primary key. So you will notice here that course code is also underlined. So the primary key, or the composite key of the relation class, contains course code and class code. So in this situation, the type of relationship that exists between course and class is Okay, strong. Okay, so that's the difference between weak and strong. Okay, next is type of entity. So we have what we call a weak entity and a strong entity. So what is a weak entity? It is a type of entity whose existence depends on some other entity. Meaning, if the parent entity does not exist, then the weak entity will not also exist. Okay? Okay, a good example is this one here. We have been using this example. Okay? So there is a relationship between employee and dependent, and you have there an employee has one or more dependent. Now, this attribute, this entity dependent, depends on the existence of employee. So dependent is actually a weak entity. Okay, why weak? That's because if we are going to remove the entity employee, then there's no need to have that entity dependent. That's why you will notice here that it says that a weak entity has no business meaning. Okay? Now that's because, again, if we are going to remove this entity, then what's the point or what is the importance of this entity? The answer is none. So since there's no importance or this entity is not relevant anymore, if we are going to remove employee, then we can say that dependent is a weak entity. Okay? Now the opposite of that is, they call it a strong entity, and it simply is an entity that exists independently of other entity type. And in the definition, it says here, most of the basic entity types. So, if we just take this as our example, is there a business meaning to this entity employee if we will remove this entity? Okay, the answer is yes. The entity, their employee, is still important for the company. It still has purpose, or it has still some relevance to the organization, even if we are going to remove that entity dependent. Because it's the employee that works for the company. So that's why, from the perspective of the company, the employee is important, because without them, the company will not also exist. So that entity is important. And in that case, we can consider employee as a strong entity. Okay? So, those are the differences. Okay, we have discussed this already. So, relationship participation. So, optional and mandatory. So, that's, if you recall this. So, and you also have this. Okay. So, this is optional participation. And that's the mandatory participation. Here. Sorry, I forgot. This is supposed to be like this. Okay, so this is an example of an optional participation. So an instance here is not required to have a dependent. So if it is required, then you have to use this vertical line. Okay, so these are the symbols. We have been using this. And then relationship degree. Relationship degree, this pertains to the number of entities that participate or are included in a relationship. So the first degree of relationship is called unary. Unary exists when an association is maintained within a single entity, which is also known as recursive. So a good example of this is this one. You have the entity employee, and then you have the relationship managers. Okay. So an employee manages an employee. Okay. So an employee manages an employee, and obviously an employee is managed by an employee. So it will never happen that employees are managed by non-employee of the company. So any person who manages certain groups of employees or everybody in the company, that person who manages is also an employee of the company. So just like what we have in Silliman. So in our college, our manager is Dr. Marshall. And he is also an employee of Silliman. Okay, so it will never happen that an outside person will do that. Okay, so if you look at now, this entity is the same as this entity. And since these two entities are the same, so we will not draw it like this. Okay? So rather we'll draw it like this. So we will erase this. And the diagram will be like this. Okay, there. So, an employee manages one or more personnel or employee, and an employee is managed by one employee only. So this is the cardinality, and this is what we call unary. It's called unary because it's a loop. Okay? Now the next degree of relationship is binary. Binary exists, or we can call the relationship binary if there are two entities that are included. That's why it's called bi. And of all the degrees, this is the most common. So an example of binary, I will not draw anymore. This one here. Okay, this is an example of a binary relationship. So the relationship has is binary. That's because there are two entities that are involved. We have employee and dependent, and that's the most common, because I think all of the relationships we had created are or involves two entities. Okay, next to binary, okay, they call it ternary. Implies an association among three different entities. Okay, so when there are now three that are involved, you call it ternary. And before I'll give you an example, okay, whenever possible. So if you can, then you decompose your ternary or higher into an equivalent binary. But of course, if you can't do it, then just leave it as is. Okay. So this is an example of a ternary relationship. So for example, you have a customer. Now a customer normally will buy something. So probably we will call that something as item, or you can call it product. Okay. So how many items? Okay, so this is buy. So how many items can a particular customer buy? So it could be one or many. For a given group of items, how many customers can buy? It is also one to many. Okay, so it becomes many to many. So since that's many to many, absurd. Okay, so it's many to many. So we will now change that relationship to an associative. So probably we will call it customer item, and customer item is an associative entity. Okay. Now the question is, can a customer buy directly an item, or does it require another person? Well, if the answer is yes, then it becomes binary, only between customer and item. So in that case, that's a self-service grocery probably. But in many situations, you cannot buy it by yourself, but you have to buy an item from someone else. So there is that person in the store where you are going to transact with so that you can buy. So there is this group. So you normally transact with the employee. So you buy those items from this employee. So in this case, the diagram now looks like this. Okay? Okay, so the diagram looks like this. So a customer is going to buy an item, okay, buy an item from the employee. So this is now what we call a ternary relationship, because there are now three. Okay, so this is also possible. So this is also possible. So in this case, there are four. And this is also possible. So it's something like this. In this case, there are six. So from 4 up, there is no specific name. Unlike 1, 2, and 3, this is just simply called n-nary relationship. N refers to the number of entities that participate. But as again, what is mentioned here, as much as possible, if you have a degree of relationship like this or even this, if it is possible, then you have to decompose it into binary, if possible. Not, then, well, leave it as is. Okay, so those are the degree. So how do we make an ERD? Okay, I will not explain this anymore. That's where we have been doing. Okay. Okay, so that's all for entity relationship modeling. Okay, the next topic, which we will discuss tomorrow, is called an enhance. It's still related to this topic, or related to the one we had discussed today, but it's called enhance. Okay, so what is this? Okay, we'll discuss it tomorrow. Okay, so any question, clarification before we call the day off? Questions? Okay. Okay,
Sir,
questions?
sir, ag-among kuan sir, assignment.
Which one?
Katong evolution.
Yes, sir. Hindi powder.
Ako karon dito na.
Yes, sir.
Yes, sir.
We create a link.
Later, no?
Oh, so you have until this afternoon.
Ay, salamat, sir.
Okay, sir.
You have until 6 o'clock.
6
Sige,
o'clock.
sir.
So I will create a link and then you upload it there. Okay,
Yes, sir.
don't forget.
Yes, sir.
Forget. Where did you get what you are writing there? You the source, huh?
Yes, sir.
Don't forget. Okay, so we will. Okay, we just have the sheet work Thursday na lang. So we will finish our discussion on extended or enhanced ER model. We will discuss it tomorrow, and then I'll give you an example. Then by Thursday we'll have a graded sheet work. Okay?
Yes, sir.
Sige. See you tomorrow.
Bye, sir.
Bye, sir.
Bye, sir.
Bye,
Thank you, sir.
Okay. Ay, lamay.